Hi guys, so this is the last video for 3C, the summary. For the first two questions, I did them in the first video. I'm going to do now this question here for number 5. They say that we have these two parabolas. There's going to be one parabola that's written in factored form. I know it's opening up. Because it's written like this, I can easily identify the x-intercept. So this one would be at 0 and this one would be at 6. And then we have a second parabola. They tell us the coordinates of the vertex, and it's going to pass through the vertex of this parabola, which they didn't explicitly give it to us yet. So we'll find out information about that. And then it says determine the vertex form of the equation for this second parabola. So again, let's try to look at a sketch. We can go to Desmos and take a look at what they're giving us. So I've already plotted them here. This purple parabola is in factored form. Again, my x-intercepts that I identified are here and here. This is the vertex that they gave us for the second parabola, so I labeled it here. And it's supposed to go through the coordinates of this purple graph, the first parabola. Let's try to get the point. And here it's identified as 3, -9. So let's algebraically try to find that first, and then try to find an equation that's going to go through this second vertex and then this point. So let's get our boards ready. Guys, I'm sorry, these lessons are kind of dry. Personality-wise, I miss the classroom. I'm sure you guys do too, but I mean, everyone stay safe. So here we have the two parabola question. This is the first parabola. I indicated it here as y1. Again, if we want to find the vertex of this, we're going to use the same technique that if it's given to us in factored form, why don't we obtain the x-intercepts, and we'll be able to find our vertex. So again, in this technique, because if we wanted to find the x-intercepts, we would technically say let y is equal to 0. They would have a 0 product. But we've looked at this so much that, you would just have to kind of switch the sign or algebraically make each of them equal to 0 so that I can find the x-intercepts. So just like in the picture, we've identified that the first x-intercept is at 0. The second one, if it reads as negative, it's not going to be positive. So again, if you do a sketch like what we had, this parabola that's opening up, you have one at 0. This one would be our pretend 6. So a parabola that's opening up would have that vertex that lies in the middle here. So let's try to find the middle of these two x-intercepts to find the axis of symmetry. So axis of symmetry, we know that we're going to add these two x-intercepts and we're going to divide by 2. So this would be 6 divided by 2, and we would get an x-intercept, an axis of symmetry of 3. So that's the picture over here. So if I know that this has an x value of 3, let's find the corresponding y value. And if I give you an x value, if you want to find the corresponding y value, you just have to put it into the original equation to generate y. So let's write y1 for the first parabola. The corresponding value would be 3, and this would be 3 minus 6. We saw what the answer was already supposed to be. Let's not write this, it's bad form. So this would be 3, and then this is 3 minus 6, which would be minus 3, which would give us a corresponding y value of -9. So our vertex in this picture, which makes sense, it goes 3 units to the right, and it's going to go some units down, and it's negative in this case, so this would be 3 and 9. Negative. So we're going to use this first vertex. So in our second parabola, they already give us the vertex of that, and we're going to use this as an x and y point to try to find it on the equation of the second parabola in vertex form. So here I wrote this other given information. This is the vertex of the second one, and now this point is this one that we found here. So let's substitute this information for ourselves. The corresponding value for this vertex for the first one is 3 and -9. So because they already give us the vertex and a point, and they want it in vertex form, I'm going to write it in vertex form. So let's do the general form for vertex form. This is going to be y is equal to a x minus h squared plus k. And again, let's do the substitution. The vertex for the second parabola that we want, so let's write y2 here. This is the appropriate h and k, and this would be our x and y point that we would write to solve for this a over here. So let's substitute the values that we have. I can take this board now. So this y value over here is -9. This a we don't know, so we're trying to solve for that. This x that we found is equal to 3. This one would read as minus, substituting that here would be -2. So again, when it reads negative, this is why it becomes positive because of these two negatives. We'll square this, and then we'll add the 5. And then we're going to use BEDMAS to simplify for a. So let's do brackets first. 3 minus -2, this is going to give us +5. +5 squared is 25. This one is going to get multiplied to be 25a. There are no other like terms for a here. This is a constant. We'll move it with this constant as well. So we know that if it's being added by 5, we're going to subtract by 5. So let's subtract 5 here and here. And I'm going to have, let's rewrite this line. On the right side, this is 25a. And then -5 minus 9. This is going to give me -14. And then I'm going to divide both sides by 25. And then I'm going to have an e value that's equal to -14 over 25. If this is reducible, then please reduce. In this case, it's not. So let's write our final equation for the parabola. This is our a value, and we have the coordinates of the vertex of h and k. So let's write, therefore, in vertex form, y2, the second parabola, is equal to -14 over 25, x plus 2. So our value here was negative. When we put it in here, it becomes positive. It's going to get squared. And then we're going to add 5. So let's check if this equation actually matches our graph on Desmos. So let's write it. Y is equal to -14. We're going to divide it by 5. Not 5, 25. If you want to move it over, you have this arrow that goes over here like this. So we'll move it over here so I can write the bracket x plus 2. I'm going to square it. We're not done. And then plus 5. So when I look at this, our parabola is in the color purple. I want it to go through its own vertex, and I want it to go through the vertex originally this purple value, which is correct that we originally found was at 3 and -9. Okay, so good.